Hello students, welcome you once again to GK's maths classes. Today we are going to solve under this 5 problem per session. We are going to do some JEE mains questions based on matrices and determinants. Okay, I hope this video will be very useful to you. So let's go straight into the problem. Now this is the first question where we'll be solving 5 problems. Let's see how it goes. Let B equal to, it's a 2 by 2 matrix. And A is a 2 by 2 matrix which satisfies, there are 3 conditions given. One is A B inverse is equal to A inverse, and B C B inverse is equal to A, and C power 4 plus alpha C square plus beta I is 0. I am expected to find the value of 2 beta minus alpha. Now to do this, what I will do first, I will start with what is given. So what is given to me? I think it's given that A B inverse is A inverse. AB inverse is A inverse. Now what I will do is I'll try to find out. I'll pre-multiply by A. Okay, so I'll get A square B inverse equal to I. Correct? I multiply by A, so A into A inverse is I. Now I want to get rid of this B inverse. So what do you do? A square B inverse into B equal to I into B. So from this we get, by associative property, B inverse B is I. So I get A square equal to B. This is the first equation I get. From A B inverse is equal to A inverse. So I'm able to get that. Now what I will do, I'll go to the second part that is given to me. What is the second part that is given? BC B inverse equal to A. It's given BC B inverse is equal to A. Now from this I will try to find what C is. To find C, what I will do, I pre-multiply by B inverse. So I get CB inverse equal to B inverse A. I pre-multiply by B inverse. Now I want to get rid of this B inverse, so I post-multiply by B. Here I pre-multiply by B inverse. In the next step I am going to post-multiply by B. So if I post-multiply by B, this will become C equal to B inverse A B. So this is the second thing that I have got from the question. Now what I will do, I'll try to find out what is C square is. So let's find out what a C square is, because I need to find what a C square is. Okay, so C square will be B inverse AB into B inverse AB, correct? Because C is B inverse AB, so C square will be B inverse AB into B inverse AB. So by associative property, B inverse is I. Okay, this will become I. So I into A will be A into A will be A square. So effectively what will I get? I get B inverse A square B, correct? B inverse A square B. If you open, it's very clear. Okay. B inverse A square B. So you have got C square equal to B inverse A square B. See, A square B inverse A square B. Now what I will do, I will try to find out what is C power 4 is. So C power 4 will be C square into C square. So what is C square? C square is B inverse A square B into B inverse A square B. So from this again, using the same logic, B inverse is I. So I into A square will be A square. A square into A square will be A power 4. So this will become effectively B inverse A power 4 B. So this is C power 4. So I have found C square and I have found C power 4. Now let's come back to C square. Now here C square is B inverse. What is A square? A square is B into B, correct? In place of A square, I substitute B. Because we can put, since A square equal to B. Now what is B inverse B? B inverse B is I. And I into B is B. So what have you proved? You have got C square equal to B. Very, very important for me. C square equal to B. Now here, if I come to C power 4, this will be B inverse. What is A power 4? A square is B. A power 4 will be B square. Correct? So which will be B inverse. I write B square as B into B. B square is B into B. So what is B inverse into B? B inverse into B is I. B square. So you get B square. So you got C power 4 equal to B square. Is it clear? So just I made use of whatever is given to me. Now I want to find B square. B square is what? B is already known to me. That is 1, 3, 1, 5 into 1, 3, 1, 5. Now, usual matrix multiplication. First row, first column. What do I get? 1 plus 3, it is 4. Then 3 plus 15, that is 18. 1, this is 6. You know multiplication, you should know it now. 3 plus this is 28. First row, first column. So I get the value of B square. So I think it's correct. Okay. So this is B square. Now this is actually C power 4, correct? Because B square is C power 4. See how nicely it comes. Now let's go back to the question. The third thing that is given is C power 4 plus alpha C square plus beta I equal to 0. Now what is C power 4? C power 4 is nothing but 4, 18, 6, 28 plus what is alpha C square? Your C square is B. So alpha C square will be alpha, 3 alpha, alpha and 5 alpha. And what is beta I? I is an identity matrix, so it is beta 0, 0, beta equal to 0. What is 0? 0 is a 0 matrix of order 2 by 2. That's done. Now you add first row, first column. What do you get? 4, first row, you add the first element. First elements you add. So you get 4 plus alpha plus beta equal to 0. That's one equation. And second equation will be 18 plus 3 alpha plus 0 equal to 0. So from this 3 alpha equal to minus 18. So alpha equal to minus 6. Once you get alpha as minus 6, substitute here. So you get 4 minus 6 plus beta equal to 0. Therefore beta equal to 2. Now that I got the value of alpha and beta, take 2 beta minus alpha. What is 2 beta? 2 beta is 4 minus alpha is minus 6. So the value is 10. See, very nicely, very simple question. Okay, only thing is you should know how to put things together. If you, you see what I did, I just made use of whatever is given. I found A square is B, I found a relation, then I found C. Once I found C, I found C square, and I used this, and I got C square as B. Then I found C power 4. Once again I used this, I get C power 4 is B square. Once you got C square and B square, C square and C power 4, take the third condition that is given, substitute here and simplify, you get the answer. And now let's go to the next question. The second question here is, if the system of equation x plus 4y minus z equal to m and 7x plus 9y plus nz equal to minus 3 and 5x plus y plus 2z minus 1 has infinitely many solution, then find the value of 2n plus 3m. Okay. Now how do I find the value of 2n plus 3n? So for that, first you should know that if a system of equation has unique solution, okay, we'll just see the formulas first. Okay, if it has unique solution, assuming that I put it in the matrix form, my determinant A will not be 0. If my determinant A is 0 and if my adjoint of A into B is not 0, then I can say it has no solution. Okay. Now if determinant A is 0 and adjoint of A into B is also 0, then you can say two things. One is it can have no solution, or it can have infinitely many solutions. These two are possible. If determinant A is 0 and adjoint of A into B is also 0, the system may be consistent or may not be consistent. If it is not consistent, then it has no solution. If it is consistent, it will not have unique solution, but it will have infinitely many solutions. Now, in this particular problem, he has made it very clear the system of equation has infinitely many solutions. Since the system of equation has infinitely many solutions, definitely determinant A must be 0 and adjoint of A into B must also be 0. So let's figure out how it works. So what is determinant of, but before we use this, let us find out what A is. So can I write this as 1, 4, minus 1, and then 7, 9, n, and then 5, 1, 2. I'm using matrix method. If you want, you can even use Kramer's rule and get it. X, Y, Z equal to m minus 3 and minus 1. M minus 3 and minus 1. So this is my matrix A. This is my X equal to, this is my capital B. So now you know what B is. Okay. So first since I know determinant A must be 0. So what is determinant A? 1, 4, minus 1, 7, 9, n, 5, 1, 2. So what is determinant of A? My determinant of A will be 1 into 18 minus n minus 4 into 14 minus 5n minus 1 into 7 minus 45 equal to 0. That's determinant A must be 0. So I have 18 minus n minus 56 plus 20n minus this will be 38. Okay. 45 minus 7 38 equal to 0. Since it is minus into minus, it will be plus. So from this it's very clear that you have 19n, okay, 19n equal to, so this is 56, correct? It was 56 and this is minus 56, so equal to 0. So obviously I got n equal to 0. So directly we got n as 0. Because I used the fact that determinant A is 0. Now I want to find adjoint of A. Okay, I am not going to do adjoint of A. You know how to find. It is nothing but cofactor of A transpose. I have already found it, so I will not be wasting my time. You can do it by yourself. What is adjoint of A? Which I have calculated. It is 18 minus 9, 9 minus 14, 7 minus 7 minus 38, 19 minus 19. You can cross check. Okay. By now you should know how to find adjoint of A. Now you know adjoint of A into B must be 0. So what is adjoint of A? I have got adjoint of A, that is 18 minus 9, 9 minus 14, 7 minus 7 minus 38, 19 minus 19 into what is B? My B matrix is M minus 3 and minus 1, right? equal to 0, 0, 0. Before finding adjoint of A, you put n equal to 0. Okay, you put n equal to 0, then find adjoint of A. So your calculation becomes simple. You won't have any n term involved. Now first row, first column. What happens? 18m, right? 18m plus 27 minus 9 equal to 0. I am multiplying first row with first column. So 18m minus plus 27 minus 9m. So I get 18m plus 18 equal to 0. So m equal to minus 1. Now that I have found n and m, just substitute here. 2 into 0 plus 3 into minus 1. So the answer is minus 3. So for doing this problem, if you want to do it by matrix method, 100% you should know this property, that if the system of equation has infinitely many solutions, definitely determinant A must be 0 and adjoint of A into B must also be 0. Adjoint of A into B must also be 0. Now let's go to the next question. We'll go to the third question. This is a question. A is a square matrix of order 3 and determinant of A is given as 3. Now he wants me to find the determinant value of this is given as 2 power m into 3 power n. I want to find what m and n is. Okay, I want to find what m and n is. Let us see how to go about it. Now, first let me write this. This is determinant of adjoint of minus 4 into adjoint of minus 3 into adjoint of 3 into adjoint of, it is actually 2a, complete inverse. Okay, close it. Now for this bracket 1, 2, 3 and determinant. And this is the determinant value. This is the value that I want to find. Determinant of adjoint of minus 4, adjoint of minus 3, adjoint of 3, adjoint of 2a inverse. Okay. You all know determinant of adjoint of A is nothing but determinant A to the power of n minus 1, where n is the order of the matrix, correct? So I'm just going to use that property. So I'm going to treat this entire thing, I'm going to treat this entire term as A. This entire thing will be taken as A. If I consider that as A, what is determinant of adjoint of A? It is nothing but determinant of A. So I'm writing A. Okay, 1, 2, whole to the power 2, because the order of the matrix is 3. N is 3, so n minus 1 will be 2. You have to keep track of all this, you have to be very careful. Okay, now I'm going to make use of this result. The determinant of Ka is k power n determinant of A. Determinant of Ka is k power n determinant of A. I'm going to use this result. Now how am I going to use? Here my k is minus 4. So when I take it out, it becomes minus 4 the whole square. Why it is whole square? Because, minus 4 the whole cube. Because the order of the matrix is order of the matrix is 3. So it is actually my k power n. Okay, k power n, but already there's a whole square, so it will become whole square into determinant of adjoint of minus 3, adjoint of 3, adjoint of 2a inverse whole square. Is it clear? So I used these two properties here. First I used determinant of adjoint of A, then I used determinant of Ka. Okay, here my K was minus 4. Okay. Now this minus 1 power, this will become 4 power 6, correct? Minus will vanish because of whole square. Now again I use that property. What is determinant of adjoint of A? It is determinant of A we have to be concentrate, okay? Whole square. Determinant A power n minus 1. Already there is a 2. One more 2 will add, it will become 4. Is it clear? Determinant of adjoint of A is determinant A to the power of n minus 1. N minus 1 is 2. So this will be determinant power 2. But already there is a square, so it becomes whole power 4. I hope that's clear. Once again, I go back to this property. What is determinant of Ka? My determinant of Ka will be, see this, minus 3 whole cube. Because my K is minus 3 and order of the matrix is 3. So minus K power 3. But whole power what? It will be whole power 4. Because we are taking out from there. Into determinant of adjoint of 3 times adjoint of 2A the whole inverse whole power 4. Now again this is power 12, so it is 4 power 6 into 3 power 12. Once again I use that property. What is determinant of adjoint of A? Determinant of 3 into adjoint of 2A the whole inverse the whole power 8. Why? Determinant of adjoint of A will be determinant A to the power of 2, but already there is a 4, so 4 2s are 8. Right? Now once again I go back to this and I apply this property. When I apply this property, it will be 4 power 6 into 3 power 12. 4 power 6 into 3 power 12. Once again here this will be 3 power 3. Why 3 power 3? This is a matrix of order 3. 3 power 3. And already it's power 8. So I have to raise it to the power 8 into determinant of adjoint of 2A the whole inverse. Is it clear? Here this K is 3. K power 3 whole power 8. So this will become, I will write this as 2 power 12, okay, and this will be 3 power 12 into 3 power 24. Now once again I use this property, determinant of adjoint of A. What is that? Determinant of A the whole power n minus 1, this is actually 8, okay, whole power n minus 1, so it will become 16. Determinant A the whole square, that will become 16. Okay, so this will be 2 power 12 into 3 power 36. Now this can be looked at as A inverse divided by 2. Okay, A inverse divided by 2 whole power 16. Now when I take 2 outside, what will happen? 2 power 12, 3 power 36. Your K is 1 by 2. So if I take it out, it becomes 2 power 3. Why it is 2 power 3? Because K is 2, order of the matrix is 3. So 2 power 3 whole power 16. Whole power 16 into determinant of A inverse whole power 16. So this will be 2 power 12, 3 power 36 divided by 2 power 48. But you know determinant of A inverse is 1 by determinant of A. So what is determinant of A inverse? 1 by determinant of A power 16. Carefully you have to do the calculation. So this is 2 power 12, 3 power 36 divided by 2 power 48 into 1 by, But you know determinant of A is 3. When I put determinant A is 3, this will become 3 power 16. This will become 3 power 16. So effectively this will be 2 to the power of 12 minus 38. 12 minus 38, what is that? Minus 26, correct? Minus 26. And this will be 3 to the power of 20, which is same as, it's given 2 power m into 3 power n. So your m is minus 26 and your n is 20. Okay. Now how do I find, I'll use some other color so I can just, you can make it. So what will be m plus 2n? Your m will be minus 26. Your n2n will be 40. So the answer is 14. Okay. So the answer is 14. You just see if I made any calculation mistake. In case I made, just make the changes. Okay. 3 power 16, 3 power 20 minus 36, 38, 12, 3 power 36, 3 power 20, 2 power minus 36 it should be. I think I made a mistake here. It's 48, right? It's 48. So it will be 2 power minus 36. So m will be minus 36. So the answer is 4. Okay, I made a small calculation mistake. Instead of taking 12 minus 48, I took just 12 minus 38. I think that you can understand. Okay. So it's not complicated. It looks complicated, but what did I use? I just used this formula, then determinant of Ka, then I used determinant of A. Only 3 formulas I used. Automatically get the answer. Nice problem. This will also help you if you do this type of work. It will also make your life easy as far as the board exam in CBSE is concerned, because you do a much milder sum, and almost all properties you use in this problem. Okay. Let's go to the next question. This is a very, very nice problem. If A equal to, if it is given that A equal to 1, 2, 0, 1, and my matrix B is identity matrix plus adjoint of A plus adjoint of A whole square into adjoint of A whole power 10, then the sum of all the elements of the matrix B is, sum of all the elements, I have to find matrix B and I have to sum all the elements there and find out what it is. So for this, what I will do, first I will try to find what is my adjoint of A is. Adjoint of A is very easy to find. Interchange the diagonal element and change the sign. Okay, this is adjoint of A. Then what I will do, I'll try to find out what is adjoint of A whole square. Adjoint of A whole square will be 1 minus 2, 0, 1 into 1 minus 2, 0, 1. If I multiply this, what do I get? I get 1, I get minus 4, 0 and 1. So I get a very nice pattern here. Adjoint of A whole square is this. Now let us also try to find out what is adjoint of A whole cube is. So adjoint of A whole cube will be, I'll take adjoint of A whole square and multiply it with adjoint of A. So what you are expecting? I think you get 1, minus 8, 0 and 1. Correct? 1, minus 6 I think, okay? Because it is minus 2, minus 4 is minus 6. So there's a pattern, you see. When it is adjoint of A power 1, it is minus 2. Adjoint of A whole square, it is minus 4. That is 2 into 2. When it is adjoint of A whole cube, it is minus 2 into 3. So what will be adjoint of A, say for example whole power r, some r times, it will be 1, 0, 1. This will be minus 2r, correct? It will be a multiple of 2. You see, this is minus 2, 1, minus 2 into 2, minus 2 into 3, so it will be minus 2 into r, correct? But I want to add all this matrix, right? So I will take sigma I equal to 1 to 10, sigma I equal to 1 to 10, adjoint of A whole power I equal to, you can send the sigma inside, I equal to 1 to 10, 1 minus 2 times sigma I equal to 1 to 10 R, 0, if you add any number of time it is 0, and sigma I equal to 1 to 10, 1. Now this is very clear that this is nothing but 10. If you add 1 10 times, you get 10. If you add 1 10 times, you get 10. Now what is the formula? Sum of n terms, n into n plus 1 by 2. Sum of n terms, n natural numbers, 1 plus 2 plus 3 up to n and n plus 1 by 2. But here n is 10. So it will be 10 into 10 plus 1 by 2. So it will become 55, correct? This is 55, this is 0, and obviously this is 10, because you are adding 1 10 times. So that gives you this, but I want B. What is my B? B is nothing but I plus sigma I equal to 1 to 10 adjoint of A power I, correct? This one, I'm writing it in short. So B is 1 0 0 1 identity matrix, and you have already found this. What is this? This is 10, 55, 0 and 10. So if you add, what you get? You get 11, then you get 55, then 0 and 11. But the question is, find sum of all the elements. The sum of elements of matrix B is 11 plus 55 plus 0 plus 11. What is that? It is 77. I hope I have not made any mistake. N into n plus 1 by 2, that is 11. Oh, I made a mistake here. I made a mistake, minus 2 into. So it should be minus 110. Correct? Because this is 55. I did not take into account this minus 2. I missed it. So it will be minus 110. So if I add them, what do I get? 111. This is minus 110. So it will be, the sum will be 11 plus minus minus 110 plus 11. So it is minus 110 plus 22, which is minus 88. Okay. So I just made a mistake here. I just took this as 55. It is actually 55, but into minus 2 I forgot to write. So I think that's clear. It's very simple, but very nice problem. Okay. I hope you understand this. Now today for the last, this is the last problem for the day, where we are going to talk about, let A is a matrix given, and you have given an equation where you have A cube, it's a polynomial in a matrix, A cube minus 4A square minus A minus 2I, where I is the identity matrix of order 3 by 3, and you have to find 2A plus 3B. Now here you can use different techniques to do the problem. So I prefer to use the characteristic equation. So I think you know what a characteristic equation is. Okay, you should know, or otherwise I'll explain to you. A characteristic equation is given by A minus lambda I equal to 0. So 3 by 3 matrix, A into lambda I equal to 0. Now what is A? A minus lambda I. A is 2A 0, 1 3 1 0 5 B minus lambda I. What is lambda I? Lambda 0 0 0 lambda 0 0 0 lambda. So A minus lambda I will be 2 minus lambda A 0 1 3 minus lambda 1, then 0 5 and B minus lambda. So this is the characteristic equation. I mean, I found a minus lambda I. I hope I have not made any mistake. 2 minus lambda a 0 1 3 minus lambda 1 0 5 b minus lambda. Yeah. Now what is the determinant value? Determinant value should be 0. A minus lambda I should be 0. Let us find out what it is. Now what happens is, how you expand the determinant. So you get 2 minus lambda into first row first column. So it will be 3 minus lambda into b minus lambda minus 5. Correct? 2 minus lambda into 3 minus lambda into b minus lambda into minus 5. Minus a into, what happens here? It will be b minus lambda. The other one is 0. So 0 into anything is 0. So this is the determinant value of a minus lambda I. So now what I will do, I will open the bracket. First I will simplify this. So you get 3b, right, minus 3 lambda, 3b minus 3 lambda minus b lambda plus 5 lambda, correct? 3b minus 3 lambda minus lambda b plus lambda square I missed, plus lambda square minus 5. Okay, 3b minus 3 lambda minus, okay, it's perfect. And this is minus ab plus a lambda equal to 0. You have to concentrate, that's all. It's not difficult, you have to concentrate on this. Now just open the bracket. When you open this bracket, you get before I open the bracket, can I do something? Okay, we will just open the bracket. You get 6b, okay, minus 6 lambda minus 2b lambda plus 2 lambda square minus 10, or you can get minus 3 lambda b plus 3 lambda square, 3 lambda square plus b lambda square plus b lambda square minus lambda cube minus plus 5 lambda minus ab plus a lambda equal to 0. I don't know whether this is correct. Let me check. 6b minus 6 lambda minus 2b lambda plus 2 lambda square minus 10 minus 3 lambda b plus 3 lambda square plus b lambda square minus lambda cube minus plus 5 lambda. Yeah, I think it looks okay. Now what I will do, I will group all this first. So can I say this is minus lambda cube? First I will write the lambda cube. Now I will group all the lambda squares together. So what are the lambda squares? So this is lambda square, and anywhere else lambda square? Yeah, there's another lambda square. All we'll group all that together and write. How do I write it? This is 5 lambda. So can I say this is 5 plus b into lambda square? 5 plus b into lambda square. Okay, that's done. Now let's go to the next one. What is the next one? I will look for lambda. This is my lambda. I have a lambda here. I have a lambda here. I have a lambda here and a lambda here. Okay, let us see. Minus 6 plus 5 is minus 1. Okay, so I'll put minus 1. I'll put minus 1. Okay, minus 6 plus 5 is minus 1. Then this is minus 2b, minus 2b, and minus 3b is minus 5b. Okay, good. Minus 2b minus 3b is minus 5b. And then I have plus a.
into lambda.
So I think I've covered all the lambdas, right? I hope I've covered all the lambdas. This is, once again, this is minus 1, then minus 5b, perfect. Okay, good. Now, what are the constants? The constants are
6b.
okay, I'm writing all the 6b. Then I have minus 10. I have minus 10 here.
Minus 10.
6b minus 10. Is there any term without lambda? Minus ab
Equal to 0.
This is what you call the characteristic equation, which is true for any system of equation. This is a 3 by 3 matrix. I got a cubic equation. Now what do you do? If you replace this lambda by a matrix A, if you replace lambda by a matrix A, you can write this as A cube plus 5 plus B into A square plus minus 1 minus 5B plus A into A plus 6B minus 10 minus AB into I, identity matrix, equal to 0 matrix. See, this is a characteristic equation with the lambda as a arbitrary scalar. But if you replace that scalar by a matrix, it becomes a matrix equation. So you got a characteristic equation. So A minus lambda I gives you a characteristic equation in terms of lambda. If you replace lambda by a matrix A, don't forget to put I here. Okay. Now what do you do? All that you need to do is compare this equation. Okay, compare. What is this actually? This is actually minus A cube. I'm taking it to that side, plus 4A square minus A minus 21I equal to 0. Now compare them. You get 5 plus B equal to 4. So B equal to minus 1. Okay. Then what do you do? Minus 1 minus 5B plus A equal to minus 1. Okay. Now B is minus 1, so you can write minus 1. B is minus 1, it's plus 5. Plus A equal to 0, so equal to minus 1. Therefore, A equal to minus 5. Now that you got the value of B, you got the value of A and B. So what will be the answer? Let me check whether the answer is right. So A is minus 5, B is minus 1, perfect. So I want to find 2A plus 3B. This is 2 into minus 5 plus 3 into minus 1. So answer is minus 10, minus 3 is minus 15. Minus 13, sorry. So I hope this is clear, but there's another way to do this problem. I'll give you the formula. You can also try. That's a shortcut. This is slightly lengthy, where I used a new idea of characteristic equation, which many people may not be knowing if you are only going through CBSE. So this is a very powerful equation from characteristic equation, how to solve it. Otherwise, you see, finding A cube, A square and simplifying it takes time. Okay. There's another shortcut. You can also have a shortcut like you can have A cube minus trace of A into A square plus sum of minus of diagonal element, diagonals of A. When I say diagonals, I am talking about main diagonal into A minus determinant A into I equal to 0. So if you apply it here, you will get the answer. I'll just show you quickly how to do it. So the matrix is actually 2, and then I'll just write on this 2A 0 1 3 1 0 5 B. This is a different approach, that's all. Now, what is trace of A? The definition of trace of A is sum of the diagonal elements. Sum of the diagonals. What is the diagonal element? 2, 3, 5. 2, 3 and B. So sum of the diagonal element will be 2 plus 3 plus B, which is nothing but 5 plus B. So this is very familiar. Trace of A is very, very important. you add all the diagonal elements. Now I want to find sum of the minors of the diagonal. So I want to find sum of minors of diagonals of A. Okay, let's look at the minor of 2. The minor of 2 will be, leave that row, leave that column, it will be 3b minus 5. That's a diagonal element, 3b minus 5. Then what is the minor of 3? Minor of 3 will be, leave that row, leave that, it will be 2b. Correct? It will be 2b minus 0. So what is the minor of b? Minor of b will be 6 minus 8. Sum of the minors, okay, so it will be 5b minus a plus 1. 5b minus a plus 1. Okay. Now you find determinant of a. What is determinant of a? Determinant of a will be 2 into 3b minus 5. Okay. 2 into 3b minus 5 minus a into, what is minus a into? A into b. That's it. So it will be 6b minus 10 minus ab. I got this. Now put it in that equation. A cube minus, what is trace of a? That is 5 plus b into a square. And what is the sum of the minus? It will be 5b minus a plus 1 into a. Then minus determinant value is 6b minus 10 minus ab into I equal to 0. Now you can compare this with the equation that we got. What is the equation we have? We have a cube equal to, so I bring all the terms this side, minus 4a square minus a minus 21I equal to 0. The previous question. Okay. So now you can compare. You get 5 plus b equal to 4. So automatically you get b equal to minus 1. That's another way to solve. Okay. And then you have 5b minus a plus 1 equal to minus 1. And 5b is minus 5 minus a plus 1 equal to minus 1. Correct? Plus minus. Okay. So what did you get here? Actually it should be plus a. When I bring it this side, so it will be plus a. So they get cancelled. So a equal to minus 5. So you have got b is minus 1, a is minus 5. That is exactly what I got here also. And you can also look at this equation. See, 5 plus b, I have got 5 plus b. Can you see it? It's the same. Then, see, look at this. It's the same. So everything will be same. So basically, when the characteristic equation is expanded and if you put it in the matrix form, this gives you the trace, this gives you the sum of the minus of the diagonal, and this gives you the determinant value. So there's something very amazing in this particular equation. I hope you understand this. So we have finished the 5 questions. I hope it is useful to you. Of course, I took little lengthy. It took a lot of time to finish this. Please go through this very carefully. We'll continue more problems in the next video. I hope it was very useful to you. Please subscribe to my channel and also click the bell icon to get notifications. Have a lovely day. Bye bye. Thank you.